Okay, dear students, let us see what is there in this question. The ball is now displaced through a small distance x from the bottom of a bowl and is then released from the rest. The magnitude of the force on the ball towards the equilibrium position is given by this. So they are saying that there is this ball there and a ball is there which is at the distance x away from the equilibrium position. Obviously the ball is being acted upon by a force and the magnitude of force is already given and we need not to think about it like what is it and how to find that. So I can just say that restoring force F is equal to mgx divided by r. Clear? So clearly the force is directly proportional to x. So if this is the case, it is definitely going to convert itself into simple harmonic motion after some time. But let us see what is the question that they are trying to ask. Now, where r is the radius of the ball. Now, a small ball of mass m is moving in a horizontal circle inside the surface of the frictionless hemispherical ball like this. The normal reaction n is this. So this is the second statement. Basically, again, because this is paper 2 question, they're having two questions which are superposed on each other. So we must be trained to understand like this statement is not actually concerned with the other statement. So this statement is only about the circular motion of the ball, but the earlier situation was about the SHM, simple harmonic motion. So there are two questions. One question is having simple harmonic motion of the ball and the other is having the ball which is moving in a uniform circular motion. Okay, so let us go for the question number 1. State the direction of the resultant force on the ball. So definitely the first question is about the second statement. The first statement, he has given the first statement, but the question is not there for the first statement as of now, because in the first statement the ball is clearly going for simple harmonic motion. Now he is actually considering only this thing. Now let us see. So the normal reaction n is given by this is theta. So there will be a weight which will be given by this w, and the state the direction of the resultant force on the ball. So we want to find the resultant force. Okay, so this is the normal reaction, this is the weight. In such cases, what happens is we just create the resultant of these two forces, and that resultant will be somewhat given by this. So this is the force that is F net, you can say this is the net force or the resultant force that is acting on the ball. Clearly, this force is acting towards the center of the circle, of the center of the horizontal circle. So this will start acting like centripetal force, and so the ball will be able to move in a circular motion there, no doubt about that. Okay, let us see. State the direction. So the direction of this is towards the center of the circle, or you can say that the direction is in horizontal direction, horizontal towards right. I would be showing you the answers also after some time. Let us see. Now, on the diagram, construct an arrow of the correct length to represent the weight of the ball. Okay, so obviously, as I have already drawn in the diagram, that the weight will be going like this in the downward direction. But the question is correct length. How are you going to find the correct length? You see, the resultant of the force was coming out to be this. It only means that this should be the weight, isn't it? Because you must be remembering the triangle law of vector addition that you might have done in topic 1. So what happens there is that this is the resultant force. So the weight as a component can be moved across in the graph without changing the direction or the magnitude. So we can just move this w from this point to this point, thereby completing the triangle. So this is the resultant. So the length of this will be equal to this. Clearly the length of the weight will be lesser than the normal reaction, isn't it? Because we can clearly see it, we can judge it like when we see it. So anyways, so this will be the answer for A2. Okay, we will be checking the answers later. Let us go for A3 now. Show that the magnitude of the net force on the ball is given by this. So we want to find the magnitude of the net force. Okay, so let us say this is the weight. I'm sorry for that. I don't know what is happening today. Okay, so this is the weight W, and the angle theta, we have to see like where the angle theta is given. Let me refer to the other diagram now. This is theta, fine, no problem. Yeah, it means this angle is given as theta. So this W can be written here correspondingly, and this can be written as the force F. Clearly, the tangent theta is equal to W divided by F, and thereby F can be taken as W divided by tangent theta. So W is the weight mg divided by tangent theta. So this will be the answer for the final force or the resultant force that is acting on this. And thereby it's clear. So 3 points question, and we have done this. You have to draw the vector triangle there, by the way, like this, and you have to show all of the angles, and this is F, this is W, like that. So this is how we do this question. So even this is completed. Let us move to the next question now. Now B says the radius of the ball is 8 meter and theta is 22 degree. Determine the speed of the ball. So again, he's not talking about the SHM now. He's again referring to the same statement. And the force is given here. This is the force. And we want to find the velocity with which the ball is moving in the horizontal circle. Whenever something is moving in a circular fashion, it got to have some force which is acting like centripetal force. So clearly this F net is now acting like centripetal force. So centripetal force can be taken as mv square by r, where r is the radius. So we can just write the capital R there. The radius is given as 8 meters, yeah, and mg tangent theta, so even theta is given. Clearly in front of you there is this equation, so we are going to write it as mv square by r is equal to mg divided by tangent theta. M and m gets cancelled out, so v square is equal to g into r divided by tangent theta, and we are now going to take the square root so that we are able to find the true value of v. Okay, dear students, so I am not substituting the values there. I'm not calculating anything. We will just see the mark scheme if they have done the same thing, and we would be getting the correct answer. You can plug in the values. The gravity will be 9.81, the radius will be 8 meter, and theta will be 22 degrees. Definitely you have to use the calculator, and then you can find the value of v. Fine. So with this, B is completed. Let us go to the mark scheme and see the answers for A and B. Yes. So in A, it says that the net force is horizontally to the right. Very good. In A2, they have shown the force which is downwards, and definitely it is lesser. You can clearly see that this length is equal to this length because they have created a parallelogram there. So even this is done. Now, let us go for, yeah, A3. So there you want to create this tangent theta kind of thing. So this is the triangle, this is theta. Clearly tangent theta is equal to mg by f, even that is correct. Let us go for the part B now. So even in part B, just a moment please. Yeah, in part B you can see B is equal to mg tangent theta, mv square by r. Clearly they have actually done the same thing. Oh my god, there is a mistake there, I'm sorry. I forgot to tell you about this. R is equal to capital R cos theta. I'm sorry. Let us move back. Yeah, so what is happening here is, you see the centripetal force, which is this force F is given by, they have written it, um, mg by tangent theta, sorry. Yeah, so this is mg divided by tangent theta, and I told you to equate it with this, and I told you that this radius is the radius of the ball, and I'm sorry for that because we are not going to use this. We have to use the radius of the circle here. radius of circle. But what is given to you? Given to you is the radius capital R, the radius of the ball. Now, from that radius, you have to find the small radius, the radius of the circle has to be found. Clearly, the small radius R will be equal to capital R into cos theta, isn't it? You can see this is the triangle that is being completed here. So small r can be written in the terms of cos theta, in the terms of capital R. So small r is equal to capital R cos theta. I forgot that. And in the place of centripetal force, like when we want to write this, this radius will be the radius of the circle, isn't it? So by mistake, I took that. So we are going to substitute this value here, and then you are going to find for V. So it will be mv square divided by capital R cos theta divided by capital R cos theta is equal to mg divided by tangent theta. Clearly m and m will get cancelled out, and you would be having a corresponding cos theta there. So fine. Okay, so B is done. This is how we do B. Now let us go to the question number C now. Outline whether this ball can move on a horizontal circular path of radius equal to the radius of the ball. So it says that is it possible that the ball be moving in a horizontal circle and this R becomes equal to capital R, like this? Is it a possibility that ball reaches this position and it goes around this horizontal circle? Is that a possibility or not? Well, my dear students, we have to concentrate here. We have to see that, yeah, there will be a normal reaction in this case that will be here. So it can create that kind of a centripetal force there if there is a normal reaction. But try to concentrate here. The weight is downwards. The weight is downwards. Now, if we say that there is a normal reaction, well, there will be no normal reaction. But even if we assume that there is a normal reaction, so normal reaction will be perpendicular to the surface, and thereby you can say it will be this. So this normal and this weight, they're having 90-degree angle between each other. There is no force that is going to balance the weight of the body. There has to be a force. In this case, in the case that is shown here, let me show you the forces. How are they working? This normal reaction is divided into two parts. Like this. So this is n cos theta and this is n sin theta. And where is the weight? This is the weight W. Clearly, there is a component of the normal reaction which is actually trying to cancel the W weight, which is downwards. So vertical forces have to cancel each other, and this n cos theta is actually equal to the F net, which is acting like the centripetal force, which is given as mg divided by tangent theta. It can also be written as n cos theta. Now, clearly in this example, there is a vertical force which is n sin theta, which is cancelling weight W. But in the other case, when the ball was here, the vertical force was not getting cancelled. So it is not getting cancelled. That is why that case is not possible. Okay, so C is done. Outline whether the ball can move in a horizontal circular path of radius r equal to radius of ball. So the answer is no. This is not possible. Let us go to D1 now. Outline why the ball will perform the simple harmonic oscillation between the equilibrium position. So that is done because it is already given that the force F is equal to mgx divided by capital R. That is given in the first statement of the question. We can clearly say this F will be equal to m into a, inertial force. M and M will get cancelled out, so acceleration can be written as g divided by R into x. Yes, of course, there is no negative sign written in this statement, but we can just assume it. So that is not a problem. So we can say that acceleration is directly proportional to x, and we can separately say that yes, the direction of the acceleration is towards the equilibrium every time. So all of the conditions have been fulfilled. Clearly, it will be performing a simple harmonic motion under the condition which is given in the question. Okay, so this is done. D1 is done. D2. Show that the period of the oscillation is about 6 seconds. So, my dear students, as I have already told you in couple of other questions also we have done this. This is a set pattern and you have to do it like that each and every time. You can even remember this pattern, like this is how you derive the formula for the time period. How do you do that? You compare this thing with A is equal to negative omega square x. Negative omega square x. Negative has been given from my side only. So acceleration is equal to negative omega square x is the fundamental equation of simple harmonic motion. Clearly, omega square will be equal to g divided by capital R. Omega will be written as 2 pi by capital T square is equal to g by capital R. From here you can find the value of T. So it will be 4 pi square capital T G by R. So T is given by like this. I think, okay, there will be a square root also. Oh, T square. Yeah. And so T is coming out to be 2 pi square root of R by G. Yeah. And so here we just plug our values there and we find the value of T. So that would be coming out to be 6 seconds. We will again, I'm not going to plug the values here. We are just going to see the mark scheme if we are getting the same solution. Let us go for D2 and let's see what is happening there. Yes, clearly omega is equal to square root of g by r. So they first found the omega and then they equated it with 2 pi by t and they found the value. So it's exactly the same thing that I have done. They have done in steps, step number 1, step number 2. I have just created a complete computational formula. You can just plug your value there and get the answer. So they have done exactly the same thing. No doubt about that. Let us move to D3 now. Yeah, D3. The amplitude of the oscillation is given as 0.12 meter. On the axis, draw a graph to show the variation with time t of the velocity v of the ball during one period. So we have to draw this graph. So with respect to time, obviously it is going simple harmonic motion. So there will be a simple harmonic graph there. So it should be v is equal to uh, the amplitude v naught and whether it is using sine or cos, uh, because we are starting our motion from that t is equal to 0. Just a moment, have they given any other information? No, of course it would be starting its motion from the extreme position only, so the displacement function will be cos and the velocity function will be sine. So velocity will be negative of v naught sine omega t because displacement will be taken in cos. So this is going to be the variation for the simple harmonic motion. V naught can be written as the amplitude multiplied by omega, and this will be sine omega t. The amplitude is given as 0.12 now. Omega we have found in the last question, but I'm not remembering it. What was it? So we can just use that value. So I'm taking it from the answer from the mark scheme. I think it was 1.1 something. Yeah, 1.1. Yeah, yeah. So omega is 1.1 into sine omega t. So the time period was coming out to be 6, and time period is not depending on the amplitude. So whatever is the amplitude, the time period is going to be 6 seconds. So this is 6. So this is 3, 50%. Yeah. Sinusoidal motion. So it will start from 0. The velocity is going to be maximum. This is 1.5. And the maximum velocity can be calculated here. So that will be, I can calculate it from the calculator, 0.12 multiplied by 1.1, which is 0.132. So 0.13. this. So somewhat here. So you are clearly going to make a sine graph. So 1.3 in the negative, 3, 4, 4.5 up to this. Yeah, this will be the graph for the velocity. But my dear students, because there is the negative sign also, so the velocity will not be positive. Yeah, velocity will be negative initially. So you have to create the mirror image for that. So our correct answer will be this. Oh my God, it's a bit confusing, so it's taking this time like this. So this will be the right graph. Yeah. So this is the right graph for the velocity versus time. So it's very confusing question, no doubt about that. It's a difficult question, I would say. There's a lot of things going on parallelly, so you have to be very careful. Okay. So it is a time consuming question, no doubt about that. Okay, so this is the graph that we have drawn. The amplitude is given. This is how we do this question. So D3 is done. Let us go and see the answer if they have done the same thing. Well, they have not shown the graph. Yeah, here it is. So first of all, the correct amplitude is this 0.13 that we have already used. So 0.13, and then they are first we would be having negative value, then we would be having the positive values. This is how we do this. Now let us go for, I think, the last part now. Oh, it's a very lengthy question, no doubt about that. It's 20 minutes already. A second identical ball is placed at the bottom of the bowl, and the first ball is displaced so that its height from the horizontal is equal to 8 meters. That is the exact radius. The first ball is released and eventually strikes the second ball. The two balls remain in contact after the collision, so it's clearly and perfectly inelastic collision, totally inelastic. Determine in M the maximum height reached by the two balls. A very important question. In itself, it is a very big question, so 3 marks are clearly justified here. So you see, first of all, we are going to apply the principle of work energy theorem there. Like, we have to first find the total energy there. So the energy with the first ball, let us assume the mass is m, and so the energy will be mgh. And when it is reaching at this point, we can just assume that the total height becomes 0. So all of the energy has been converted into kinetic energy. Thereby, we are going to create our that famous formula, that is V is equal to root of 2gh. So this ball, while it is going to collide with the ball, the velocity attained will be square root of 2gh. So this is the velocity with which it is going to collide now. So here, just before it collides, we are going to concentrate at that point. So this is the diagram before collision. This ball is at rest. This ball is moving with the velocity v, and after the collision, both of the balls are sticking together. So they are sticking together, so they are moving together. It means now the mass is 2m, and it would be going with the velocity capital V, I can say. I've taken it as capital V. Do not get confused, okay? This is small letter v. So clearly, I would be applying the conservation of linear momentum principle here. So this is the mass. So before collision, it is m into v plus 0 is equal to, now the total mass is 2m, and now it is moving with the capital V velocity. So mv is equal to 2mv. M and m is getting cancelled out. So capital V is half of it. Because the mass is the same, these balls are identical. Clear? So now it will be moving with half of the velocity. So if it is moving with half of the velocity now, so now we have to apply the conservation of energy principle once again to find what is the total height that it is now going to rise. Okay, so what is the kinetic energy now? So this is the second case. Clearly it has nothing to do with the earlier now. So the total mass is 2m g What is the energy? Sorry, we have to take the kinetic energy now. Half m v by 2 square. So this is the total kinetic energy. This will be equated with the total potential energy, which will be 2m g into h dash. This height is h dash. 2m and 2m are getting cancelled out. It becomes v square by 8 is equal to g h dash, and we must find the value of v square. So velocity we were finding from this point. Okay, so we have to first find this. So the velocity will be, or v square. Okay, we can find the velocity here mathematically and we can substitute the value here. Or if we are clever enough, we can say v square is equal to 2g h, and h is given as 8 meter. So directly I can substitute the value of this, like 16g will be directly substituted there in the terms of v square. So this becomes 16g. I substitute it here. 16g divided by 8 is equal to g into h dash. So g and g are getting cancelled out. This will become 2. So clearly h dash is coming out to be 2 meters. So earlier it was 8 meter, and now the height attained will be 2 meter. So my dear students, this is how we do this question. You can pause the video to see this thing. You can repeat the video to see this thing. Be very careful. Like as I earlier told you, that this question in itself is a very big question. It can command the 5 points also instead of three. Like this is that big a question. First of all, we are applying the principle of conservation of energy. Then we apply the principle of conservation of linear momentum. Then we again apply the principle of conservation of energy. So it's a very long question, no doubt about that. It would be taking more than half an hour for you people in the examination hall. So let us verify from the mark scheme. We are getting the answer 2 meter. Okay, so the velocity is 12.5. VC is this. So the height that we are again attaining is 2 meters. No doubt about that. So I believe that